These are the answers to numbers 13 and 14 on the momentum review. Number 13, a 575 kilogram Jeep runs into the back of an 825 kilogram car. The car is at rest. They move off together with a speed of 8.5 meters per second. We're going to assume no friction with the ground right after the collision, so we're going to find the initial speed of the Jeep. We're going to use conservation of momentum. The momentum of the Jeep plus momentum of the car equals momentum of the Jeep after the collision plus momentum of the car after the collision. Initially, the car has no momentum because it's not moving. So we have mass of the Jeep, velocity of the Jeep equals mass of the Jeep, velocity prime, plus mass of the car, velocity prime. They move off together, so those two velocities on the right side of our equation are the same. Solving for velocity of the Jeep, I just have to divide by the mass of the Jeep over to the right, and that's why I have my fraction here, mass of the Jeep, v prime, plus mass of the car, v prime, all over mass of the Jeep. Plugging in my numbers, mass of the Jeep was 575 kilograms, initial speed, the speed after the collision was 8.5 meters per second, plus mass of the car, 825 kilograms, times 8.5 meters per second, all divided by the mass of the Jeep, 575, and I get that the velocity of the Jeep before the collision was 20.7 meters per second. Number 14. A .05 kilogram bullet is shot into a 2.5 kilogram wooden block sitting on a table. The bullet and block slide along a table a distance of 3.4 meters. The coefficient of friction between the block and the table is 0.28. We're going to find the initial speed of the bullet. So I have the mass of the bullet was given, mass of the wooden block was given, the distance they slide off together is 3.4 meters, and I have the coefficient of friction on the table. The issue here is we can't immediately jump into conservation of momentum. There are too many things we don't know. We do not know how fast the bullet and block slid off together. So I don't know the speed, or v prime, over here on the right side of the equation. So since I don't know v prime on the right side of the equation, I can't solve for velocity of the bullet over here on the left because I've got too much stuff I don't know. So I have to go into either forces and kinematics, or in this case I used energy to find out how fast they were moving at the start. So we're going to get that 4.32, and here's how we do it. Initially, the two things move off together, so they initially have kinetic energy. There's no potential because they're not on a hill. There's no elastic bands or anything. On the right side, they eventually stop, so there's no more kinetic energy. There's no potential energy. It just all was thermal energy. So 1/2 mv squared of my kinetic energy equals my friction times the distance on the right side. Well, I don't know what friction is, but I know friction is mu times the normal force. Well, normal is up and force of gravity is down. They're equal to each other because it's a nice flat surface. So the normal force is mg, mass times 9.8. So that's what I plugged in for force of friction, mu times the normal, or mg. And then I have to remember to keep the d over here. I have an m on both sides, so they cancel out. So it doesn't matter what the masses are. We do know them, but they would cancel if we didn't. So I get 1/2 v squared, that's how fast they're moving off together, that's actually v prime when we use it when we are solving in momentum, equals mu times g times d. Solving for the velocity, we're going to get rid of the half by multiplying by 2, so there's a 2 over here, and I have to do the square root to get rid of the squared. Plugging in my numbers, I get the square root of 2 times 0.028 times 9.8 meters per second squared times 3.4 meters for a speed of the bullet and block together of 4.32 meters per second. That's going to be the v prime, how fast they moved after the collision, down here when we do conservation of momentum. In conservation of momentum, initially the bullet has momentum, the wooden block does not because it's just sitting there. And finally, they're going to have momentum right after the collision because they start sliding off. So here's my simplified equation without momentum of the wooden block in there, and now I just have to plug in mass times v for each of my momentums. Mass of the bullet, initial speed of the bullet, equals mass of the bullet v prime, plus mass of the wooden block v prime. And again, that v prime is the same because they move off together. Solving for the velocity of the bullet, I just have to divide by the mass of the bullet over to the right. That's why it's in my denominator now in this step. Plugging in my numbers, I get the mass of the bullet, 0.05 kilograms times 4.32 meters per second plus 2.5 kilograms times 4.32 meters per second, all divided by the mass of the bullet, which is 0.05 kilograms. That tells me that the bullet had to have been going 220.32 meters per second.